Hello and welcome to Math at Marvin's. As you can see, we got our nice little classroom set up in my living room, a giant whiteboard I was able to take from the school. So this way we can actually get some stuff done, try and move forward. So today, we're actually moving on to the next lesson. We are talking about solving systems of equations by elimination. So before we were doing substitution, just a quick reminder on that, because it's been forever since we've done math. What we were doing before is we were saying, like, if you can get y by itself and have it equal some junk, then we can plug that junk in for y in the other equation. Now, what we're going to see is when we get problems like this one. Okay, we have 2x plus 5y equals 17, and 6x minus 5y equals negative 9. Okay, what you'll notice is there are no variables that are alone. There's not even a solo x or y that we could solve for and then plug back in. So instead, we're going to use a different method. We're going to use elimination. And the idea behind elimination is if I can find two variables that match up nicely, meaning they're about the same thing, they can multiply to be the same thing. So in this case, I have a positive 5y and a negative 5y. Okay. Then what we're going to do is we're going to add or subtract these equations. Now, I'm going to teach you the way I do it, which is always adding. So basically what you want, a big asterisk over here, you might want to write this down. You want opposite signs on eliminated variable. Because what that allows us to do, that allows us to then add, because you'll notice what happens if you would take a positive 5y and a negative 5y, what's going to happen to those variables? Well, they're going to go away. They're going to eliminate each other. And that's what we're looking for. So in this case, opposite signs on eliminated variables. Positive 5y, negative 5y. Good, I don't have to deal with that step. Okay? So, all I'm going to do is I'm going to add these two equations. I'm going to add these two equations. Okay? So pretty easy, 2x and 6x. Well, that's 8x. 5y and negative 5y we just talked about. Well, that's 0y. So really, I'm writing it just to show you. You absolutely do not have to write that. And then finally, on the back side, we get 17 plus negative 9 is 8. What you'll notice now is you have a single variable equation, which is where we've been trying to get to before. It's what we were trying to do with substitution. So now, nice and easy, I have 8x equals 8. I'm going to divide both sides by 8. Therefore, I know x equals 1. Once you've reached this point, it's like all the problems we've done before. Okay, it's like all the problems we've done before, where if I know one variable, all I have to do is plug it back in. I'm going to pick the easier one. Ooh, in this case, not really an easier one to pick. So I'm just going to plug it into the first one. So I do 2 times 1 plus 5y equals 17. Okay? I apologize if you can hear my dog whining. She's trying to get outside through the glass door and is upset that someone's walking by. Lily, no. All right, we're going to finish this problem with Lily. So in this case, I know x equals 1. So now when I go to solve it, all I have to do is move my stuff around. So I can subtract my 2 across, subtract 2. I get 5y equals 15. Okay, 5y equals 15, which means there's one last step. All we got to do is divide by 5. Divide by 5. Y equals 3. Okay, so now we have the point, the x and the y coordinates for our intersects. I don't want you to forget what we're really finding is these are two lines. We're finding where they intersect. So in this case, they intersect at the point 1, 3. Okay, 1, 3. So those two lines, they intersect. Now, the one tough part I'm going to tell you now, we're not really going to deal with it today. I might put it on one of your challenge problems at the end of this, but one thing you might run into is if they're not in this form. Okay, if the two equations are not in standard form, or at least similar, like these aren't exactly standard form, you might have a negative a value, so it wouldn't really fit that idea. But if they're not there, so if we have an equation, so just an example here, if we have an equation that's something like y equals 3x minus 2, in order to use it, you have to line up all the variables. So what I might have to do is I can always move things the same way I solve, and I can just move the x over. So minus 3x, and then what I would have is negative 3x plus y equals negative 2. Okay? So that was just an example. That was a side example that had nothing to do with this problem. I just wanted to show you something we will run into later. Kind of get it in your head so that way if it shows up, you don't get stumped. But for now, let's move on. Similar problem here on number 2. Okay, also don't forget, make sure pause the video if you need to. Go back, I'll give you a clear look here. Go back, write all this down if you need to. And then as always, make sure to email me if you have a question on something I did. Call me out if maybe I did something wrong. There's always that possibility. Or email me if you need to have a Zoom meeting if it's something you want to talk to in person. Okay? On to the second one. A little bit different because what you'll notice is negative 2x plus 15y equals negative 32, 7x minus 5y equals 17. Ooh, x's don't match, y's don't match. Well, the good news is they don't always have to be identical. All we have to do is find something that can multiply into the other. So if you look closely here, negative 2 and 7, not ideal. Okay, you'd have to multiply both equations. But if I look, I have 15 and negative 5. So if I could turn this into 15, everything would cancel out. Well, from our basic equation rules, we know we can always, you can always multiply an equation as long as you multiply everything. So in this case, we look at it and go, all right, what multiplied will get us to 15? So we need to multiply by 3. So I'm going to multiply every piece of this bottom equation by 3. Okay, oh, just stepped on my dog. So now we go ahead and multiply. Remember on this side, we do need to distribute. So what I end up with is 21x minus 15y equals 30, 21, 51. Okay. Now I have two equations, so I can bring down, I'm just going to bring down for working sake my other equation and put it underneath. So negative 2x plus 15y equals negative 32. And now, because I have a positive and a negative, I have opposite signs, I have them matching numbers so that they'll cancel, I can add straight down. So I go here and I get, okay, 19x plus, these are going to cancel, so I'm not even going to write it this time. Negative 32 is plus 51 is going to be another 19. Looks like we're going to have another nice one where x is going to equal 1. That will not always be the case. We just happen to get two of them in a row. So x equals 1, and we're right back to what we've done before, where you take that variable, you plug it back in. I'm going to plug it into the first one, negative 2 times 1, so it's just negative 2, plus 15y equals negative 32. I'm going to add my 2 across, add my 2, a positive and a negative going together. So what I have is negative 30. So when I divide this out by 15 and 15, I get y equals negative 2. So in this case, these two lines intersect at the point 1, negative 2. Okay? So, one thing to remember, I don't make you do this, but you can always plug it back in and check. We should be able to plug in 1 and negative 2 back into either one of those equations, and what you should get is two numbers that are equal to each other. That shows that the solution works in both equations. All right, last little piece we want to look at before I give you some things to practice on, just a couple little practice problems. In this case, we have something a little bit different. It might look the same. You got about the same setup here. 2x, 6y equals 18, x plus 3y equals 9. So we don't have anything that matches. In fact, the different part about this one is we don't even have opposite signs. But that's pretty easy to fix. So you pick, in fact, in this case, either one of them is going to be pretty easy to do. I'm going to do the x because I like smaller numbers, a 2x and a 1x. pretty easy. I'm going to multiply the bottom one by 2. But like I said, we want to remember our rule over here that says opposite signs on eliminated variables. So if the x is what I want to eliminate, then I need to make it not 2, but -2. Okay, pretty easy. All I do, multiply everything by -2. If you're getting junk answers, one of the biggest problems people make is they forget to multiply everything. So if you're getting a fraction, you're getting a really ugly decimal, go back and look at this step. I'm gonna guess if you made a mistake, you forgot to multiply the other side of the equation by the number that you were multiplying by, okay? In this case, we get -2x plus -6y equals -18. Okay, terrible negative sign. Now we're ready to go. Pull down my other equation, and they should be ready to add if I did this right. 2x plus 6y equals -18. Okay, so when we go to add, you have a -2 and a +2. Pretty easy, that cancels. We have a -6 and a -6 and a +6. Those are also going to cancel. So what I have left on this side is nothing, which is 0. On the other side, I have -18 plus -18. Or sorry, I miswrote that. See, I almost made an error and we would have gotten the wrong answer. I made this negative, okay? +18 and -18, those also cancel, okay? It's the same rules you learned on elimination, or sorry, on substitution. If you get something that is true, 0 equals 0, that's true, okay? If 0 equals 0, well then I know there's 2 possibilities if there's no variables. It's either infinite solutions or no solutions. In this case, because it's true, we know these are the same line, therefore this is infinite solutions. Okay? Infinite solutions. So, the other option would be if you got something like 6 equals 0, something that doesn't make sense, then that would be a no solution example. Okay? Otherwise, those are the 3 types of examples basically I can show you. The one we didn't get to, and I'll make sure to put one in your practice problems, is something where it's not in this form. It's not quite ready to go, so that you have to make some adjustments. Okay? Otherwise, that's our lesson for today. I'm going to pause this quick. I'm going to write some practice problems up on the board. I'd like you to take a shot at them. If you get them, it means you're good to go. You know what's going on in the lesson. If you need some help, shoot me an email or text a friend that's in here. Call somebody, Zoom with me, Zoom with a friend, do whatever you need to do. But you got to use your resources, especially when we're in this weird time where we're kind of all stuck at home and we can't be working face-to-face. Again, hope you're having a great day. Enjoy your quarantine. Make sure you're finding a way to stay entertained as well as stay busy. Let me know if you need anything. Shoot me an email if you just want to say what's up. Love hearing from you guys. Miss you guys. Hope you're having a great time. And there are your examples to get done. Let me know if you need anything.